Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hello, everyone. Hope you're having a wonderful summer. I'm Olivier Poupani, the head of developer relations at Orchis, and in this session today, we're going to talk about generative AI orchestration and more particularly, how to manage document processing using GenAI orchestration. And for that, I would like, before really jumping into the core of the topic, to go over some generative AI use cases. Probably you know a lot of them, but I would like to go over them to make sure that everyone understands where the document processing is coming from. So as you can see, probably there is a lot of use cases linked to dynamic content generation mostly for e-commerce applications, but we can also see GenAI in all of the customer support activities that can be automated responses by introspecting some documentations that you already have and you want just to have an automate, can be like a chatbot to answer to some customer questions. Can be, and this is what we're going to see today, all document analysis and classification. And we can see also use cases in market data for financial services, market data analysis and distribution. There is a good use case for that for generative AI. And also, I'm not sure if some of you already use generative AI to get some code automatically generated. It can be a good way also to learn how to code certain part of things, or everything that is in your part of the learning curve on a specific technology. In today's session, we're going to focus on one use case that will be how to automate document classification. So what is exactly document classification? It's really how to categorize documents into different categories based on the content of the document, the structure, and the data that is also part of the document, of course. What is the benefit? It allows organizations to manage really a large volume of documents because it's automated. And it can also, based on the content, help the decision-making process. So that's a good part. But document classification is also how to organize document into categories that will quickly identify and access to the relevant information that are inside those documents. So the real life use cases of document classifications, we can see that in spam detection, for example, if we want to focus on security. We can see all opinion classification and social listening, that is for all sentiment analysis. We talked about customer support before. That's exactly the thing, how to triage the right support agent based on the ticket that is submitted. It can be also when you want to onboard client, or you want to, let's say it's a bank and you're in the loan process, and you need to retrieve all the documents. You need to make sure that it is the right person. So you need to scan the document and classify if it is like the weight of the document. If it is a passport, for example, or a W-2, then it's going to be more weight in the required list of required documents for the onboarding process. It can be also like when your insurance is asking for some proofs of or some inspections on your house or your car, or during a car accident, you send the picture and there is some object recognition that is automatically made. So a lot of real-time use cases to receive, for the organization to receive the document and then process that document in a way that it can automate a lot of things. So of course, in many of those use cases and usages, there are a lot of challenges, and it can be some manual errors. The document is not fulfilled well. It can be also scalability issues when you receive too much document at the same time and your system cannot process. It can be time consuming with delays if you're not using, like if you're using like people to really go over each document, look in the document and make sure to take the right decisions. It can be security issues because of a pile of documents on the desk. How we're going to manage all of that at the end of the day? You're leaving your desk, you go home, the documents are still probably there. It's a risk. And also, if you're in a regulated environment, it becomes pretty challenging to manage all of those documents. So generative AI and automation will really help in that. But how do we overcome all of those challenges using GenAI orchestration? The first thing is to have a scalable orchestration platform. We saw that in the challenge, scalability was an issue because one particular person cannot really manage all of those documents. So how an orchestration platform will help to scale. This is the example of Orchest Conductor here. That is basically a workflow engine that offers a lot of different capabilities in that will be to first define your workflow, then execute the workflow, and we'll see in a second what exactly means a workflow and the tasks that are executed for each workflow. But basically, the most important thing is to keep the state of the execution of each workflow. This product has been, the genesis of the product has been made at Netflix, when Netflix really wanted to have a system to manage all the microservices execution. And one of the things that was really important at that time was, and this is the reason why the product has been made, everything can fail. And we do not develop today, unfortunately, because of the network, because of the services that can be our services or external services. A lot of things can happen, and a lot of failure can happen at any time of the execution. And because the application flows are becoming more and more complex, it is very important to make sure that we keep the state of the execution. And if something happens at each step, we can act upon. So as you can see in this schema, the workflow execution service keeps the state, and for each task, a queue is created and will manage the execution of the task itself. So whatever will happen on any of the workflow, everything is backed. Even the platform can go down. When the platform will go back up, everything can be restored properly and re-executed where it stopped. A lot of opening through the API to what we call the task worker when a task needs to be written by code, and everything can be coded in any language there. But also, if we want to integrate with external system through events, a lot of possibilities here to connect to all of the messaging system like SQS, Kafka, RabbitMQ, and so on. Of course, the cloud storage integration with Azure, and others, and a way to look at metrics to make sure that the execution of workflows can be introspected the right way so that we can know how to make them better, more efficient by looking at the execution. If you look at the anatomy of an orchestration here, and then we're going to see how to integrate all generative AI capabilities, an orchestration is really a way to make complex flows very easily. It's a list of tasks that can be executed in series, that can be executed in parallel, that can be conditionally executed, that can be executed a certain number of times using loops. So it's really the logic of your application that everyone used to code that can be replicated in a flow. But the most important is that each task can be, if there is a failure on each task, you can really manage what to do. It can be just to retry, and you can also define the number of times you want that task to be retried to make sure that the workflow can be completed successfully at one point. But sometimes the workflow cannot, and the task will never be executed. And for that, you need to branch to a compensation workflow that will do some cleanup for some data that could have been created by the previous tasks. You can define also timeouts. You can define the limits if you don't want one particular service. And believe me, with generative AI, it's very important to make sure that you don't go over limits, because otherwise you may pay a lot of money at the end of the month. So all of this can be just defined as parameters and no more something hard-coded. The good thing also is when your workflow is executing, you can visually debug what's going on even before the workflow is completed or stopped because of a failure. So if you see that the workflow is paused because of a failure, you can visually and see exactly which task is referring to the error. You can introspect that task and see the log that is associated. And of course, if it is an error in the code of the service that is associated to that task, fix the code, relaunch the code, and restart the task. All of this makes a new evolution in the tech stack for applications, and we can see orchestrations now as a real defined layer in the tech stack. If you look at, this is really over like the last 30 years probably, the evolution of the tech stack. If you see where we are right now in distributed systems using microservices, orchestration become really a layer that will help all other layers to be integrated all together, especially between the backend or the back for front, between all the APIs, between the real-time streaming events, and all the data that can be relational data, that can be metadata, that can be what we have right now, generative AI data coming from models. And that's good transition to how do we connect applications with LLM models. So for that, it's in an orchestration, it's pretty straightforward, a few steps. First, you need with a product like Orchest Conductor to integrate your models with the platform. The second part will be to create AI prompts. We'll see in a second what it means exactly. And then use AI agents. This is a term that is becoming very famous these days. Everyone is talking about AI agents. AI agents for a workflow is really one of the tasks that the workflow can execute. And of course, run your workflow to do your process. So here you have the example of a flow that is doing document classification, where first we're going to see if the document type is the right one, and then we're going to ask AI we're going to extract the content, like doing a scan of the content that is inside, and then give it to a model to tell us what is that document. So how to integrate LLM models with Orchest Conductor? You can integrate with any model provided by any AI providers. We have connectors for all of them, and this is a list, but this is of course something that changes pretty much maybe not every week, every day, but every week probably. Because of new models available from providers. It can be your personal model as well that you can deploy on your Azure OpenAI environment. But it can be some of other famous ones as well that you may have access to. And of course, because we don't want just AI to reply, and we want to avoid all of the hallucinations that can be made by common models. You can also create embeddings with some integrations with vector databases like Pinecone, MongoDB Vector, or Waviate, and make sure that after creating those embeddings, you can retrieve the embeddings to prepare a context that will be used by another task to query the model. And we are here really in a RAG framework kind of execution. So models, AI providers, models, and vector databases are the integrations that you can do with Conductor. Prompt engineering. When you have those integrations effective, the next step is to define some prompts. So let's see what does it mean exactly. Prompt engineering is really the process of structuring text content that will be interpreted and understood by a model, meaning it is a description in a natural language of what the model has to do and how it has to do it. Prompt engineering is the term that refers to the practice of writing prompts and can be kind of part of coding right now. Of course, you're coding in a language like C#, like TypeScript or others, but prompt engineering became really one part of the coding that will make your application at the end. Next step will be creating a workflow with AI agents. How is it? We have in Orchest Conductor a lot of different AI agents that are represented as tasks. Those agents are what? You can do text compilation, you can generate embeddings or store embedding or get embedding when you want to deal with a vector database. You can index documents, you can get a document, you can index just a text. A document usually refers to a URL, but if you have a content that has been generated by one task, this is something you can just pass to a similar task that will index not the document, but the text. You can search an index, and you can Chat Complete also is an agent that can help to create some answers that you can give to the end user. So that's pretty good list of different tasks that refers to really AI execution here. So after this brief introduction with slides, let's see it in action. I'm going to stop sharing the slides and I'm going to go to I'm going to make sure that I'm still connected. Yeah. To my Orchest console, where I can see all the definitions of all of my workflows, and I prepared here document classifier or workflow that we can go over. So it starts when the workflow is executed, is going to start. So by definition, workflows have, of course, input and output. So here, the input parameters will be a document URL. From that, we're going to check if the URL contains, if it is a PDF or not. So we're gonna see if the URL ends with PDF or not PDF. Otherwise, we're going to say not supported. This is to show you. It can be, of course, more complex, but this is really to make sure that to show you how we can make a switch. If it is PDF, then we're going to go to the get document. Otherwise, we're going to generate an error and we're going to terminate the flow here. The get document will just get, and we're going to make sure this is a PDF with a media type. So from the input document, input parameter of the workflow, we're going to get the URL and we're going to get the document. This will generate an output. And from that output, we are going to call our AI agent that will here do a text compilation to tell us what is this document. So we can classify what it is after. And for that, we're going to use a LLM provider. In this case, it is Mistral AI. We're going to use a model. All models are provided by their AI provider. So in that case, we're going to get the Mistral Large latest. So it can be OpenAI GPT-4, it can be any kind of model associated to their provider. And we're gonna define also which prompt template do we have. And then we're gonna say the text that will be used by the prompt in order to query the model, to tell the model what to do, will be the output of the get document task that is previously in my flow. And the next step is to extract the classification and get the text and say either the classification has been, and we get the result, or we say we couldn't be classified by the LLM, the document. This example is something that if you go to the developer playground, play.orchest.io, that you have in the chat, the link that you have in the chat, you can do your own by, I'm going to go back to the definition of the workflow, by just clicking on the little arrow of the define workflow button and say select template. And you have different templates you can use, but we have document classifier here as a template. So you just click on import and you will have this in your own, as your own workflow. And then you can play with, you can integrate with your own AI provider, you can create your own prompt and do all of the tests that you want. So we saw that the workflow relies on integrations of models and the prompt. Let's see about integrations. The integrations that we had was Mistral, and I prefixed with my initials. This is really going to the API Mistral.ai. we put a relevant API key, and that's it. And once we have this integration in place, we just have here to edit the models. And we can say we want this one. If I want to add another one, I can say, sorry, here I said edit. If I want a new model, I click on new model and I put the name of the model that is provided by the AI provider. Once this integration in place, I define the AI prompt. So here I have my doc classifier prompt. And this one says that by using this model, so from the Mistral integration, I want the Mistral large latest, but I can say also some other ones. So it can be like OpenAI, Root, and GPT-4 as well. And I give the prompt template. Here we can say we have a document that was scanned using OCR, and you need to classify the document based on the content. The document could be one of these: W-2, driver license, pay stub, employment verification letter, mortgage application. If the content doesn't match, you just reply no match. If it's not, you give us the content. So that's basically what the prompt is doing. And this will do everything. And we can test with the model if you have already a text you want, and then you can refine your prompt in order to have a relevant execution. But I don't have my document here, so I can't. I need to execute my workflow for this example. So next step will be to execute the workflow. I'm going to go back to my document classifier, and I'm going to go to the run part. I already prefixed my document value. So the document we're going to try to give here is this one. As you can see, this is the W-2 of Jane Doe that is living in Denver. Going back to the execution here, I'm going to reset the history to make sure. I'm going to run the workflow, and this is what happens. So first, the check has been done. The check has been done, and the output of the check was, yes, it's a PDF. So we are here in the get document task. It's not totally live. I need to refresh by myself, or I can automate which every 5 seconds or so whatsoever, but I can click here to see what's going on if the task is completed. Task can be completed, like it can be very long. If we are in a long running workflow, that can be like for 3 days because there is some kind of manual activities that are required. At least I have always a way to manage and introspect my execution here. So what the document said, we got the document and we retrieved all of this content. So that's the result. And the next part was to introspect the model. So we're gonna see here, so that's the input of the text, that's the prompt that we are defining as well. So what this task did is giving the output. The output is the workflow is a W-2 form. And then it explained as well how the determination has been based on. Here it's because of fields such as employee social security number, identification number, etc. And this is typical of a W-2 form. And also we see that we found W-2 wage and tax statement in the text. So there is, of course, no there is no risk that it's not a W-2. It's for sure W-2, and we know why, thanks to the model. So as you can see here, it's pretty much straightforward. But I wanted also to show you how you can introspect in a case of an error. So if I go back to the definition, and I'm going to run it again, but I'm going to say here, I'm going to remove that part. So it's not PDF, it's going to be PF. If I run the workflow, as you can see, it's an unsupported file type. So we went after the check for PDF in the case, the default case that is we generated an error and we terminate the flow. We didn't go through the model. This is also important to have all of this to make sure that you're not consuming the model for nothing, because every time you consume the model, you're going to pay. So here it has been terminated. There is another try that I can do. Sorry, I'm going to go back to the definition. I'm going to run it again, but this time I'm going to put PDF, but I'm going to put a wrong URL. So I'm going to say it's not, I'm going to remove the first I. So it's image processing. So the URL is wrong. Let's run the workflow with this. As you can see, I'm not failing still because this task actually has failed just for the first attempt. But the second attempt is now in the wait, and there will be 4 attempts before the task will be considered as a failure, and the flow will be failed. But I'm still running, so I can really keep make sure that things can be resolved either because of bad parameters, or if I say, oh yeah, it was a bad parameters, actually what I need to do is to terminate. I can really terminate by myself and say there is a problem here. So now it has been canceled, but we can introspect, and this is again very important when you're in a regulated environment and you need to show and proof that everything has been executed properly. You know that the first attempt has been made. You know that the second attempt has been actually canceled. So this one is canceled. The first one is failed. Everything is stored in the execution. You can come back. You can fulfill your compliance system with that. It is something that if you have to code it by yourself, there is no way your application can do that. The last thing I wanted to show you based on the execution, sorry, I need to go back here, run. So I have my history here, and remember that the first one went well. We went to the execution, everything went through the get document, and we saw that it was a W2 document. But what I can also introspect is, was it efficient? And for that, I can introspect the timeline of the execution. And I can see that my get document took 271 milliseconds. The check took almost nothing. And the LLM took like a little bit more than 2 seconds. And then the classification itself, almost nothing. So by that, you can also, let's say you have multiple models that you want to make in competition with themselves. By the introspection, you can see which one is the fastest. You can see which ones give the output that is the most relevant to answer to the customer. If it is something that you need, like a chat completion agent or something like that. So that is pretty interesting as well to see the timeline of the execution. If the tasks are in parallel, it's even better because you're going to see really that they start at the same time. Some of them took longer than some others, but the rejoin before going forward in the flow can be something that also, so one task will wait for the other to be completed. Or you can say, I don't want to wait. This is also a choice you can do when you define your tasks. So that's pretty much what I wanted to show you. I give you an example of document processing. I give you the access of the playground and a way to do it by yourself. You can go to your AI provider, your favorite AI provider, and have, if you have like an API key, you can define your own integration. You can use that integration. You can define your own prompt. You can put your prompt in the flow that I showed you, and do all of your tests. And of course, come back to us in any case if you have more questions. If you like it, if you have feedbacks, we are very interested by those feedbacks. I wanted to continue in the slide part to tell you also that Orchest is open source. The open source version doesn't have all the integrations with AI, but it's also something you can use to be more familiar with workflow executions and how to define workflows. This is you have the link in the chat as well, and of course, if you like it, to make it more famous as it is, we have more than 13,000 of stars right now, but it's never enough. So I will be super pleased if you can give us a star. Having said that, I'm going to open the floor for a few questions. Don't hesitate to use the chat window for that. One of the questions that I used to have regularly is it possible to use my own model? And the answer is, of course. If you go to your Azure OpenAI platform account, you can upload your own model there, and then this will be it will be possible through Azure OpenAI to use that model, integrate that model into Conductor, so that you can use it in all AI agents that are provided out of the box. Another question is, what about if I need to do a task that is not one of the tasks that is provided out of the box? So for that, we have the concept of task workers. I'm going to go back to my workflow definition here. So basically, if I go back to my workflow, I'm going to click on the plus, and this has access to all of the tasks that are provided out of the box. And this is by category. It can be the system task, like I want to call an HTTP service, for instance, or I want some operators. I want to switch while, I want to wait for a certain period of time. I want a dynamic task, which means that I wanted to execute the task, but I don't know which one yet. It depends on parameter that will be sent before. And all about AI agents. But we have something called simple task or worker task. So in this kind, you can say, this is my task. And I can give a description. I can give a reference name that I can use in input parameters or in some other task. But by doing this, I am able now to do any code using any language, can be Python, can be TypeScript, can be C#, can be Java, can be Golang, and using those languages and of course the SDKs that we are providing for that, just in a few line of code, you can develop your task. I can show you one example in my visual code. Let's say here. So one worker is just this. This is an example in Python. I have one worker that is called validate order, for instance. I just have to define it is a at worker. So using the at worker task decoration, and I put the task definition name, this will work. So for my task, for example, I just have to do one function that will be task definition name, my task. And here I do one function that can be my task or whatever. In Python, it's more with underscore, my task. I can have an input parameter or not. It can be like param. It's a string and it returns a string. So that's a simple hello task. And here in the definition, my task will have an input parameter, param1, and that can have some value. So the value can come from, it can be, for example, the workflow document URL in this particular workflow. But just doing this definition will execute this code wherever the code is deployed on the cloud. It can be your cloud, it can be on my local machine, it can be anywhere. Wherever the workflow is, wherever the worker task is. So if I want to do something very specific in manipulating some AI models, I can define that. I can define my own task, and I can refer it here by my LLM task or whatever. No more questions? All right. I thank you for your participation today, and I invite you to go to the Microsoft Reactor site and check out for the next session that will be for next month. Thank you.